Good morning, everyone. Thank you for joining us. First, I would like to thank Julie Carson and Jean McAvoy from the UF-IFAS Center for their help and cooperation. Today's program offers one CEU for pesticide license renewal and one CEU for certified crop advisors. Again, if you need CEUs, email Jean your name, email address, and license number. Our guest speaker this morning is Dr. Megan Dewdney. She is an associate professor at UF-IFAS Citrus Research and Education Center in Lake Alfred. The title of her presentation is Scouting and Management of Post-Bloom Fruit Drop, Citrus Black Spot, and Citrus Canker. For post-bloom fruit drop, Naples and Valencia oranges have been experiencing the most severe damage in Florida because they tend to have extended or multiple blooms. Groves with persistent patterns from the previous year should be closely examined once the bloom begins. Groves with a history of PFD should be scouted twice weekly during the bloom period. Concerning citrus canker, it is still a devastating disease in Florida. It causes defoliation, fruit drop, and dieback. Grapefruit and early maturing oranges are highly susceptible to citrus canker. Canker losses can be severe under Florida conditions and can be difficult to control on sensitive varieties. For oranges with endemic canker, most infection will occur from April to July. Therefore, the first chemical application may need to be scheduled in late March. For citrus black spot, this fungal disease can affect all citrus cultivars commonly grown in Florida. However, lemons and Valencia are highly susceptible to this disease. CBS causes fruit blemishes and fruit drop. Each load of fruit harvested from a quarantined area is required to be covered by a tarp in accordance with federal regulations. Black spot chemical treatment should also start early in April. It has been very good that scouting is becoming a common practice for Florida citrus growers and production managers. Scouting not only helps growers control pests more efficiently, but also lowers the use of pesticides and the chance of pesticide resistance and contamination. Dr. Dewdney will be talking about the scouting and management of citrus black spot, post-bloom fruit drop, and citrus canker. She will discuss the symptoms and how to recognize the diseases, the best management procedures, and pesticide recommendations will be presented. Dr. Dewdney, please go ahead. Thank you.
Thank you, Mongi, for that introduction. So as Mongi explained, I will be talking about post-bloom fruit drop, black spot, and canker, and I'm going to do it in that order. Hold on. There we go. So first, post-bloom fruit drop. Just as a reminder for everybody, this is a fungal disease. It really prefers the humid subtropical climates. Florida is sort of just on the edge of its preferred habitat. It really likes the weather in Central and South America. It moves with rain splash and windborne rain. And our activities, things like moving our equipment, keep having things like petals land on you, all of this sort of activity can move the fungus somewhat, but it also moves by splash. And it's more severe in areas where we get multiple blooms or varieties where we get multiple blooms, such as the navels, anything that has a long extended bloom, either because of weather conditions, like we're going to probably see this year, or HLB, which also attenuates that bloom and stretches it right out on parts of the diseased parts of the trees. So some of the symptoms, they're peach to orange colored lesions. They're on the petals almost exclusively. They can blight the entire cluster or a single blossom. And the fruit and petals fall, or the fruitlet really, fall, leaving a button, and those buttons can last on the tree for about 18 months, and you can sort of figure out if they're a PFD button. One, they start to look quite a bit enlarged compared to what you would expect otherwise from just a fallen flower, but also you can pull on it and it doesn't detach and it stays there for up to 18 months. And those are very diagnostic for the disease. There's a few other things that cause that type of persistent fruit calyx. And then the leaves around the infected flowers often will twist and remain small, and they can look a little bit like a rosette. So here's the symptoms. Change on my laser pointer here. Here are the symptoms. So this is a case where the whole cluster is starting to go down. You see that brownie color on the petals, and these fruitlets are starting to degrade, and they will likely drop a few days after the picture's taken. You can see the twisting in the leaves. Here's some very showy symptoms. Managed to catch this on a dewy morning. You can see that these petals are heavily affected. You can even see the circles of spores. And this is a very high inoculum source, which is waiting for a water droplet to come through, land on it, and then splash that disease over to some new petals or another cluster. Here we've got an example of a whole cluster that had the disease, and you can see there's fruitlets starting to degrade, and these buttons here are holding on for the time, probably 18 months for that cluster. And again, here we can see a cluster where these buttons are starting to really grow, kind of like they still had a fruit attached, and they are, and these other fruitlets are slowly senescing, and they're going to drop. So this is the PFD disease cycle. I borrowed this one from some of my Brazilian colleagues, so ignore the Portuguese on here, and I will explain what's going on in this image. So the disease really gets started in a block. Either it moves in via wind and rain here, as you can see, or on young trees coming in from the nursery sometimes, although I think that's probably less common, but also it can move on bees and such things if they happen to be pollinating flowers that are infected. So that it goes from, so we get inoculum in the grove. The inoculum is remaining on the leaves, the shoots, and sometimes the buttons, although those tend not to be a major source. It's really on the leaves and the shoots. So these fungal structures are stimulated to form spores, as you can see here, by the exudates that are coming out of the very early flowers in the season. Those then form, you can see here they're starting to germinate, form just a few spores. They then get splash dispersed, so they get picked up by rain, and they land on the next wave of flowers. Those then infect, and we start to see symptoms on the flowers. And that's when we start to get the much more large number of spores being produced in the second type of sporulating structure that this fungus has. This is all asexual spores, so there's no mating requirement. It's just a different phase of that asexual life cycle. This is where we really get a lot of spores being formed on the flower surfaces. They then form more spores, then they have many more spores to be picked up by the next rainstorm, and they go on to the next cycle of flowers that are available, and that continues as long as you've got rain and flowers together, and then ultimately you get these buttons being produced on the plant, and that shows you that you've had infection with the fungus Calotoxicum acutatum that causes PFD. And sometimes it happens so quickly that all you see are the buttons. So the fungus survives on the leaf surfaces, twigs, and in the buttons in specialized structures, fungal structures. Those structures will germinate and they form new spores with moisture and petal extracts. Those spores are dispersed to new flowers via rain splash. They germinate with moisture in 12 to 24 hours, so relatively quickly. Average is probably 16. They infect in 24 to 48 hours. And then the whole cycle continues, as I said, until you no longer have flowers and rain at the same time. And you get new symptoms and spores in 4 to 5 days. So it's relatively quick, and it's sort of timed with the flower life cycle. So the last few years, we've been lucky to have very dry springs in terms of PFD. I think that's caused some other issues, but in terms of PFD, it's been a lifesaver. So this is the climate forecast for winter in 2021-22. So this interval right now. And the consensus forecast is for a high probability of La Nina pattern. And this is the 3-month forecast. So February, March, April, so that's where we are now. And you can see that we're very likely to be in the La Nina pattern, up to almost 80%. And then it dips down a little bit as we head towards the summer months. But by that time, bloom is probably close to finished, if not finished. So there's only a 40% chance of neutral pattern by the time we get into March. So that means that we have about higher than average temperatures predicted, and rains are predicted to be below average. And I was looking at some forecasts just yesterday to see if that was still the case in the near future. And it looks like we are again expecting slightly higher than average temperatures and slightly below average rainfall, which in terms for any flowers that are out there, that means that they will likely stay PFD free, which is good. However, things can change. If we are just unlucky to have a coincidence of warm rain during bloom, then you may end up with an infection event, even though the whole forecast for the spring is for limited rain. So if you are uncertain as to whether an infection event is happening, I always recommend that people check out the Citrus Advisory System, or CAS. This is our PFD decision support system on telling us when it is likely that we should be spraying. This is hosted on the AgriClimate website. It's under the drop-down menu of tools and then crop diseases. And each circle here on the map represents a fawn weather station. And you can see they're throughout the state of Florida. And to begin, you would click on one of these weather stations. I always recommend people to get an account. That way you're getting alerts. You can mark your specific blocks of interest. So this happens to be one of my blocks that I have at the CREC. And they're both maps and satellite views to help you find your block and then to mark it out. And then it'll give you the specific risk for your assessment for your locations that are of interest. This has the advantage of that it'll send you an SMS alert for each location that you ask it to, and that can, or it can do an email notification, or you can do both. I've done both, and I found that quite helpful. So over the last few years, we've been looking at seasonal differences for PFD outbreaks, because this presentation is sort of aimed for down in the southwestern area. I looked at the historical weather data for Palmdale, Clewiston, Okeechobee, and Immokalee. And we have, as we did previously, split the season into pre-flowering and flowering seasons. That pre-flowering season gives you an indication of inoculum buildup in the off season. And I know that we have had some buildup in the off season because I've had phone calls already this year talking about, well, I've either seen stuff on my early bloom and I think I've got enough to do an application. Is it wise? And so we know that the disease is out there. It has been building up, particularly on things like navels. And then we have the actual risk for disease where we start to get into the actual sort of bloom period from January 15th to April 1st, really concentrated in March. And we've calculated the number of moderate or high alerts and then summed the total value of days with PFD alerts, just to give us an indication of how much disease intensity has been out there. So to look at that, here we've got Clewiston first. The way these bar graphs work, or these not pie charts, I should say, work. So we've got pre-flowering season here, and then the flowering season. And then in blue, we have, oops, there we go, moderate risk. In red, a high risk, and then alert-free in green. And then I've split them up by year. So here we've got historically 2015, 2016. That was probably our last major year with disease. 2016, 2017, 2017, 2018. I skipped one year because I was running out of space on my graph, and it looked a lot like these two, 2019, 2020, and then last year, 2021. And so you can see here, 2015, 2016, we had a fair amount, a high number of alerts, moderate alerts, and a few high ones in the preseason. That set us up nicely for when we did have these few moderate and high alert days. And they were a very small proportion of the, about 10% of the days during the flowering season, but they were just at the right time, and they landed in and caused a fair amount of infection that year. 2016, 2017, you can see we had a very limited buildup in that early season. It was relatively cool. It wasn't a lot of rain happening when it was warm, and you could see that there was almost nothing in the year, and that's reflected in these numbers down here, where when there were days that were alerts, there weren't even particularly high amounts of very high number of heat units or wetness. And then similar here, we have about 30% of the days had moderate alerts in the preseason. It looked like we might get something, but then there was no rain during the spring, or if there was rain, it was quite cool. 2019, 2020, similar story. Few more days during the flowering period with a moderate alert, but they just didn't really land at the right time in terms of bloom. 2020, 21, I thought we might get some disease this year because we certainly had a buildup in the early season, and I was getting phone calls about it. But then when we actually got to the main bloom period, it very much fizzled, and we saw almost no rain during that period of time at all, and only one day with a very marginal, at least in the Lake Alfred area, very marginal infection event. In Immokalee, we see a similar pattern for 2015, 2016, where we had a fairly decent buildup in the early season, and then we also had a fair number of days with infection events in the flowering season, and again, they happened at just the right time, and you can see that they weren't the most intense imaginable, but they were relatively high. Then again, in 2016, 2017, from 2016 to basically 2020, we saw some buildup in the early season. We were seeing in fact blossoms out there, but by the time we got into bloom, we were starting to get these cold fronts with rain. But every time we had rain, it was cool, and therefore there was no infection events predicted. Last year we had that very intense sort of early season, fairly high buildup of heat units and wetness at the same time. But by the time we got into the actual season, we did see a little bit of PFD, but not all that much. In Palmdale, we'll often see a few more heat units in Palmdale, but and 2015, 2016 looked very similar to other years. I think here the Palmdale station was not working, but nowhere else saw a lot of infection, so I imagine it looked a lot like some of these other graphs where we see from 2016 to 2019 very little in early season or even in during flowering. Last year it wasn't quite as intense as down in the Immokalee area, but we did see a fair number of days where we had moderate infection events, along with one day with a high infection event. And then you can see, but in the actual period during bloom, we ended up very dry last year. Last area, you could see Okeechobee is a bit more exaggerated. Possibly there's some humidity coming in from the lake area. You can see that we had a lot of heat units last year in the early season, and I don't know if they saw a bit more PFD down there. Certainly there was enough moderate days that they might have, but I'm not 100% sure. So what are we looking at for this year? So this is from October to yesterday. I calculated these out. What are we seeing so far in this year? So we're seeing a buildup. Some places a little bit more and a little bit less. Lewiston, we're seeing sort of about 25% of the days have potential infection events and a fairly high number of heat units. So if there have been flowers out there, they probably have a little bit of disease on them. Immokalee a little bit less, but every day that we have registered as a having enough heat units and wet, then we have had quite a bit. Palmdale and Okeechobee, again, are quite high in terms of the number of heat units. Now, this is a little bit longer period of time. That's up until yesterday from October 1st. But still, it gives you an idea that if there have been flowers out there, there's a good chance that they have had a little bit of infection. So the inoculum is there. Probably we're just waiting to see that when the flowers come in en masse, are we likely to get an infection event? And if anything, if it was like anything like last year, the rains pretty much stopped by the time we got to March, and we didn't see a significant rainfall until, unfortunately, June, which was great for PFD management and probably not that great for the tree health in general. So control options, removing your declining trees. If they're really not profitable trees, you may want to just consider taking them out in terms of PFD management. If you've got trees that look pretty nice, but you've got branches because they've got HLB that are flowering way ahead of everything else, that's your inoculum source for your actual profitable branches, and you may want to take that out. The fungicides, we are still fairly heavily reliant on strobilurin and containing fungicides. Those are Abound, Gem, Headline, Amistar Top, Pristine, and Preaxor. These are best combined with Furbam at high alerts. So if you were looking at a block and you notice that you have a high alert for with a lot of flowers for Furbam, then or for spray, then you probably would want to combine that with Furbam. Now, just as an aside, the EPA is looking at deregistering Furbam. So if this is of interest or concern to you, there is a comment period open right now with the EPA. So if you, that's open to the public. So if you were interested, you can either contact me and I will send you the information, or I can always post that up somewhere if people are interested. So there are strict, but I do want to point out that there are strict label limits for these fungicides for resistance management purposes. And so if you're using them for PFD, you can't really use them later in the season for other problems, because you're only allowed to have 3 or 4, depending on the product, applications in an entire season. And that's the class of fungicides, not just individual products. So the trial data that we do have from 2016 and earlier shows that our newer premix fungicides, Pristine, Preaxor, and Amistar Top, are all pretty reasonable controls for PFD, and they do give us at least some rotational modes of action so that we hopefully don't wear out our strobilurin fungicides too quickly in terms of resistance. And that's where having that Furbam in the rotation also does help, is for resistance control. So moving on to citrus black spot. So citrus black spot, sort of like another annoyance for many people. They don't know how it might affect them. Still, I do want to point out that it's caused by the fungus Phylostictus citricarpa. It can cause up to 60% yield loss. That's mostly from fruit drop in severe situations where it's not being managed. More commonly, though, you'll see fruit drop levels of 10 to 20% in a minimally managed block, but that's still a pretty significant number of fruit, especially right now when we are experiencing limited yields. We want to keep every fruit we can on the tree. If you're producing fresh fruit, then there are export restrictions to certain regions, particularly the EU. and that makes it more complicated to get your fruit to where you would like it to go to that market. And there's a lot more rules that you need to follow. This is a quarantine disease. As Mongi mentioned, it leads to requirements like tarping, which are pretty unpopular, and also increases your costs due to additional fungicide applications if you're choosing to actually manage it. It seems to be still spreading. CHIRP and FDACS continue their scouting program each year as the fruit ripen. New blocks have been identified each year so far, although when I was talking to Callie Walker, mid-January, at that time, they had not found any new blocks this year. And I was recently checking the maps, and that so far has held up this year. Fingers crossed that remains the case. But that would be the very first year that we haven't had expansion of the quarantine zones, at least minorly. It is now present in 5 southwestern counties, as well as Polk, right on that southern border. Glades County was the most recent county with quarantine zones, mostly in commercial groves. We did have a residential find in 2019 in Lee County, and it appears to, based on the symptomology and the intensity of the symptoms, it was probably present in that location for well more than a year. And apparently there had been a subsequent find made relatively close by to that original find in a residential area. So it can spread in residential areas. That's something that I think we'll have to just keep an eye on over time. I think Irma will haunt us for a while yet. Irma likely moved black spot into those new areas, and it's difficult to determine how far the disease may have moved. And that has to do with that long latent period this disease has, where we don't see spread up to 5 years post-storm. This will be our 5th year, so fingers crossed that we are hitting that point where we're not seeing an expansion because of Irma. And it's if you're downwind from black spot groves, you're probably still at a significant risk for an outbreak, maybe not specifically from Irma, but just from general windstorms and thunderstorms, depending on how those move, and those can be fairly unpredictable. So you should be scouting regularly for symptoms. You should be asking CHIRP about a multi-pest survey if you're concerned that disease is in your grove. And the spread from Irma is really in addition to what would have occurred anyway. So this was sort of just an additional way for this fungus to move around. So just to give you an idea of what that's looked like over the years, black spot was found where this is a picture or a map of where black spot was before Irma in 2017. Just as a reminder for everybody, black spot was first discovered in this region, and then in this region a little bit later in 2010. But that was really late in the season, and many blocks had been picked prior to us realizing that there needed to be scouting. In 2017, though, we were restricted still to 3 counties, primarily in Collier and Henry, but there was a small incursion into the eastern edge of Lee, mostly as quarantine zones. So it was fairly confined, and you can see sort of how it was spread out here with that little map. Now we're into the current, this is the most current map available from FDACS. These are the current locations in Southwest Florida, and you can see now we're into 5 counties. We had an intensification towards on the eastern edge of Lee. This is our residential area that it has been found in. And then you can see up in northern Lee, and then it's crossed the Caloosahatchee into Charlotte County was first. And it's intensified in Charlotte over the last few years in these regions, and then into Glades County. And if I were into Soto County, I would probably be, especially if I was close to this border here, I would be worried that I might be next on the list. But that's hard to say whether that will come to fruition or not. I hope not. And this is the path where Irma went, the eye of Irma approximately went, and then the winds would be circling this way. If you're not in a survey area, but you're still concerned about black spot, I think you really do need to learn and recognize the symptoms and scout training your grove workers to keep an eye out for unusual things. We can train staff on request. I haven't had very many requests for that, but you know, we still like to put the offer out there if anybody's interested. Contact CHIRP and arrange for a multi-press survey on property. You can contact them through this number here. If you want to scout for CBS on your own or have your staff to do it, we recommend that you wait for color break or about a month before harvest. This disease pops out on maturing fruit at close to maturity. Would recommend visiting multiple locations in your grove. That's because the disease tends to be initially found in small clusters with 3 or 4 trees in sort of a small area, and then you'll have a sea of asymptomatic trees surrounding that. Particular areas of interest where you might be getting incursions are along roads, near staging areas for equipment or fruit trucks, anywhere that you might clean equipment, that kind of thing. And then declining trees tend to have a bit more disease on them. For some reason, the disease tends to express there first. And then sunny sides of the tree tend to have symptoms on them first, and that has to do with the ripening process of the fruit on that side of the tree. So looking at the potential scouting pattern, my little dots, you want to do something like an X pattern. My little dots represent 3 to 4 rows. So you know, try to do like something like an X where you're coming through, you're looking at these trees, going a few more trees, stopping to look at a tree, trying to get sort of a wide view of as many trees as possible without being too inconvenient. Or you could do something like a W pattern, or you could look at the edges and then somewhere a couple spots in the center. But the idea is to try and get as much of the grove as possible. So we have currently recommended products are still in the 2021, the 21-22, sorry, Florida Citrus Production Guide. Recommend alternating copper with whatever you're using at a full rate of whatever your preferred product is. With a strobilurin, a premix, or enable, we know that these fungi are quite susceptible to strobilurins, at least currently, and hopefully for a long time yet. But it is still preferable to alternate amongst your modes of action. Remember that black spot's not the only organism in your grove. You also have other things like greasy spot and melanose and other fungal diseases that will also be being treated at the same time or being exposed at the same time. And so you want to think about that in terms of management. Again, your strobes are abound, gem, and headline. And remembering that you have 4 applications of this during a year. And so if you've already used 2 up, say for PFD, that only leaves you 2 for black spot management or any other fungal disease. The pristine, your premixes again are pristine, which has an SDHI product in it, Amistar top, which is a DMI, and Preaxor, again, an SDHI, and all of those contain strobilurin as well. With this disease, as with many of the fungal diseases, coverage is really important. So you want to go at least 125 gallons per acre, and try and go as slowly as possible as feasible. Timing is always important, but all citrus is vulnerable, but those lake hanging sweet oranges are the most susceptible varieties in Florida. Our goal is to maintain coverage on the fruit, a minimum of once a month applications for best control. We recommend starting in May generally. If it's really rainy in April, you may want to consider protecting those young fruit, and then going all the way through to September. And the goal is to try and keep the fruit on the tree. We did do a fungicide trial for CBS in 2019-2020. Unfortunately, we weren't able to do the 2021 season because of COVID restrictions on limiting our ability to get into the groves at that time. This was a collaborative effort with Oscar Batuman at SWFREC. We took this trial in a grove that has a fairly high CBS population of 20-year-old Valencia. And the trees were evaluated for citrus black spot symptoms before the trial in March 2019, and we looked at 25 fruit per tree. And we tried to use those initial ratings to make the disease levels and the treatments as equivalent as possible. Now they were there were a couple problems with that, and that didn't work out the way we had wanted. And I'll show you that in a second. But the application dates of the fungicides were in May and mid-May, early June, late June, July, and then August and September. And this was all applied with a handgun. And then we came through and evaluated in March 2020 with 50 fruit per tree. We have another trial in the ground that we started last year in 2021 in March. And we were collecting the data for that trial in mid-March this year. Unfortunately, we're just a little bit early for that. So unfortunately, my best plans of having the equivalent amount of disease in each rating didn't come to fruition. You can see that we have definitely a difference between the amount of disease between treatments. Sometimes things just go awry, but I do want to point out how much disease we had in here. We had a fair amount of disease on the fruit for on the whole in this trial before we started. And just keep that in mind. So this is the treatment list. We looked at Moravis and then Moravis top. So that's a SDHI, and then the SDHI mixed with difenoconazole, which is also an Amistar top. We looked at Enable, which is a DMI, like difenoconazole, Amistar top, which is a mixture of strobilurin and difenoconazole. And we rotated that with Coside 3000. Looking at Luna Sensation, which is a strobilurin with an SDHI, Luna Experience, which is the SDHI mixed with a DMI, which had reported good results in Brazil. PhD, which is polyoxin D salt, and then rotated with Coside 3000. Preaxor, looking at pyroxastrobin, which is a strobilurin, and fluxapyroxide, another SDHI. Headline rotated, just straight headline, rotated with Coside, and then an untreated control. So the first thing I want to point out here is that we had almost no disease that year, and that has to do, I think, with environment and the amount of rain that we had in the spring. But I'm not 100% certain why. But in general, there was just very low disease. Here's my untreated control. You can see that this product here, Moravis top, something was unusual about this particular treatment. I'm not sure why it had so much disease. It didn't make a lot of sense because you can see that the straight product, Moravis, is way down here. So I don't want to say that this product doesn't work. All I can say is that something seems to be unusual with that treatment. However, everything else did significantly reduce the amount of disease compared to the untreated control. Some things did better than the others. So this is the product that we were testing that was recommended from Brazil. It does not seem to do as well as some of the others. Here's straight Enable. You can see it doesn't work quite as well as some of the other products, but it's still doing better than the control. And then everything else is significantly better than the control. In fact, we could barely find any diseased fruit on the trees, which is very promising. But disease levels were very low, and sometimes things look surprisingly good under low disease situations. So can only take so much from this particular trial. When we looked at drop fruit, because of course that's one of the things we want to prevent with our fungicide programs, again, Moravis top sort of stood out with its large number of dropped fruit. It was more than the untreated control, although not significantly different. All of these treatments here were not significantly different from the untreated control, so about equivalent numbers of dropped fruit. And then you can see here that all of these treatments then had significantly fewer dropped fruit than the untreated control. So it does look like we can, with the right products, reduce fruit drop, which is promising. But again, with such low disease in that year, it was hard to really make a whole lot of solid conclusions with that, which is why we haven't changed the recommendations. I also did a skirting trial in this grove, although in a different block. One of the questions we wanted to ask was, does skirting trees improve the outcome of our fungicide programs? and does applying fungicide treatments earlier or later than the current recommendations improve how well we're controlling disease? So we had 4 treatments in this trial. The skirting was done on June 4th in 2019, and then we applied the fungicides in rows that were skirted, but also rows that were not. And we had a standard fungicide program. We've got both, so you can see the dates here for each year, but we're looking at a bound, then coside 3000, another coside 3000, pristine, rotated again with coside, and then in a bound. And the cosides here were sort of to try and think about a little bit about melanose management as well as black spot management. So what you might conceivably use for management of more than one disease. And then in our early CVS program, we added enable at the beginning of the season. And then for our late fungicide program, we based it around, again, our standard fungicide program, but put enable at the end. And then we compared that with a no fungicide control program. So the first thing we looked at was how much disease was, whether each tree was diseased within our treatment rows. And in this graph, we have, in this set of graphs, we have each year, so each season, so 2019 and 2020. We have fungicide treatments here, and then how much disease we observe, how many trees we observed with disease on the y-axis. And then we looked at, in the blue bars, no skirting versus skirting. And in the first year, I want to point out one that we have relatively low disease. So about 50% of our trees in some treatments were with disease, a little bit lower in the fungicide treatments. But there was not a real significant difference amongst these treatments. And you can see that the skirting effect is not consistent. It's not, you know, if you skirted, you have more, or if you didn't skirt, you have less, or vice versa. It's very dependent on each fungicide program, which was a bit odd. When we looked at 2020, again, it's the same idea where we have fungicide programs and the amount of disease. Here we had a lot more disease. Nearly every tree had disease. And we saw no difference in our treatments here, although skirting did tend to have a little bit more of a positive effect, but it was not significant. And neither were the fungicide control programs in terms of whether a tree had disease or not. And so that was interesting. When we looked at disease severity, so that was whether a tree had disease, and this is how badly were the fruit affected per tree. And here you can see we had each season, again, here we had very low severity, so very few trees with a lot of disease. There was a bit, but not a whole lot. And again, there was no significant difference amongst our treatments. And that was probably because there was very low disease. So basically you're comparing between 0 and just above 0. When we look at the disease severity in the next season, you can see that there was no, well, skirting again is not it's not a consistent effect. What we did see, though, was that that the controls were higher than most other diseases, although not necessarily always significantly. You can see we have a little bit less disease in the early and the standard, and then the late applications of fungicides, but there's no differences amongst the fungicide treatments. So moving that enable back and around really didn't make a big effect in these years. So what did we learn? Well, one thing that we learned was that skirting did not appear to improve fungicide programs, and perhaps we didn't keep this trial going for long enough to get a longer term effect that has been suggested. And I do want to point out that there are other good reasons to skirt for disease management, particularly for things like brown rot. If you've got a block that's had problems with brown rot historically, you're going to want to pull the skirt up off the ground to allow for not knocking the fruit off with your herbicide booms and other actions in your grove. Did applying those fungicides earlier or later than the current recommendations improve disease outcomes? It didn't appear to, at least in the 2 years that we tested. With the higher disease pressure, the fungicide use was quite beneficial, but it's really hard to predict whether your year is going to have a lot of disease pressure because it's all going to be dependent somewhat on the summer rainfall, and that's really hard to determine, coming up into a season. It's really hard for anybody to prognosticate whether there's going to be a lot of summer rain or not. So I do want to say that in 2020, we did end up starting that trial a little bit later because of COVID, but the weather was very dry in that early season. Again, thinking about the PFD weather, it's the same phenomenon there. It was very, very dry, probably not a lot of infection happening in that early season. And maybe that was partly why we didn't see an effect with that early treatment. The wetter summer, though, in 2021 did appear to affect how much disease was present. We also collected the data about 3 weeks later than 2020, and that doesn't seem like a whole lot, but sometimes for black spot, that can make a big difference. And we did see a lot more severe symptoms like virulent spot in 2021. And one thing we've noticed over time in all of the work that we've done in this grove, that black spot is steadily increased no matter what we do as the disease intensifies over time. So management, thinking about back to management specifically, the first thing you need to know is whether you need to worry about the disease. Is it in your area? Is it in your grove? Are you near a transport corridor or processing packing facility? You may want to check the quarantine information periodically to see what has changed in terms of quarantines, and then do some scouting on your own or contact CHIRT for multi-pest surveys if you're really concerned. Then I would recommend putting in a fungicide program, looking at multiple modes of action for resistance management, certainly using copper as an alternation. Managing your leaf litter, talked about that in the past to enhance the effect of the fungicide program. Soil status looks like it's pretty good at reducing the amount of inoculum in the leaf litter, or composting is also, we've had anecdotal comments that composting worked quite well. Particularly this is if you've got severe disease. If you've only got a few trees that are currently showing symptoms, there's probably less of a need for that, but as the disease intensifies, it may be something for you to consider. Try and remove as much of your dead wood as possible and destroy it on site. The Canadia are found in those twigs. They're not at huge levels, but they are there. They are able to then drip down through your canopy. And then you want to also make sure that you're practicing vehicle and equipment decontamination when you're leaving affected sites. I know that that's a real pain. It's something that's tedious, and some of the products are somewhat corrosive on rubber seals and such on your vehicles. But you don't want to spread this disease by yourself. You'd rather just let it do its spreading on its own. If you reduce, and the one thing I do want to note is that if you reduce or eliminate your CVS management program, this disease will return. It hasn't gone away. It is in the canopies, hiding, biding its time, waiting for you to dial back your CVS management program, and then you'll find in a year or two that it's back, and it's back with a vengeance. Okay, my last disease here that Mongi asked me to talk about was citrus canker. I don't have a huge number of updates here, but I've got a few slides nonetheless. Just as a reminder, the life cycle of citrus canker is not too complicated, but it starts with wind-blown rain, and it carries inoculum to the uninfected plant parts, things like your younger flush, developing fruit. That wind-driven rain then forces the bacterium in with water congestion, and they get a nice column of water that they can take advantage of and then swim into the plant surface and through the mesocell and the stomates. That we see the results of that activity in a few weeks with cankers on limbs, fruit, and leaves, of course. Having wounds on the plants will enhance that. So that's why we don't recommend hedging unless it's relatively dry. So right now would be a good time, and allow those wounds to heal. Then we get infections on fruit, foliage, and the young stems, we get then rain again. That allows those lesions to become waterlogged again. The bacteria can swim back out and get picked up by the gusts of wind and rain, and then blow it over to the next tree, and the whole cycle just continues over and over again until the tissue is no longer susceptible, or we stop getting a lot of rain. Fruit susceptibility to canker, particularly in oranges, is from 3/8 of an inch in diameter until the fruit reach approximately 1.5 inches in diameter. Those rains in April, May, and June really promote early season infection, which is particularly important on processing oranges. That's where we get our fruit drop coming from. Even rains in March have been fingered. So if we ended up with a sudden rainstorm in March, particularly now that we're getting earlier and earlier bloom, and that really can affect our timing of susceptible fruit size, those fruit become very vulnerable to rains that come in those earlier months, before when we used to think when infection was occurring. That rind becomes a bit more resistant in the fruit at 1.5 inches in diameter, and so they're a little bit less susceptible to the disease, and the lesions won't get as big. They're less likely to drop the fruit on the ground. Now, if you're growing processing oranges, that's perfect. You don't need to worry about it as much. However, if you're growing things for fresh market, that's still a big concern. Nobody's going to want to buy fruit that are all covered in small canker lesions any more than they will large ones. As I said, fruit start size matters. You really want to look at your copper sprays when the fruit reaches 3/8 of an inch. You need at least a 21-day interval to protect fruit, possibly shorter if you get major rainfall. Spray volume and your tractor speed, again, is important for fruit coverage, so you want to slow down. And that 21-day interval is based on the amount of residue that's still on the surface of the fruit. It's reduced by rain washing. It does not move. Copper does not move once it's dry, so you get cracking from that by fruit growth. It tends to look, if you look at it under a microscope, it looks a lot like a dry creek bed or a pond puddle, and you can see the cracks in between the mud. That's what the copper looks like as the fruit cracks and grows. The copper model is still available if you don't want to schedule. A lot of people, just for convenience, like to schedule their applications. The one advantage of the copper model is it will tell you when your residue is insufficient for control, but it will also tell you when you don't need to put out an application because you haven't had a lot of rain and your fruit aren't growing quickly. So those are the advantages. Looking at proper applications of copper, always as a reminder, use your label rates recommended for disease. For canker management, you can use lower quantities of copper. For fungal management, you tend to need the higher ranges of copper concentration. Be cautious though, whatever reason you're using copper. In that hot weather, you get a lot of phytotoxicity. We get some very interesting fruits sometimes coming in covered with various burns. And this can happen more easily in hot weather, above 94 degrees Fahrenheit. If you're using oil, that can enhance the problem. You can reduce your potential for phytotoxicity to put it out with more water. Always be cautious with complex tank mixes, oil applications, and nutritionals. All of these can contribute to phytotoxicity, particularly as they make the tank mix more acid, or you have oil there that kind of makes the cuticle a bit more permeable. Then that's when we start to see phytotoxicity. And so those are our recommendations. I have a little bit of data to show. Unfortunately, I didn't get a chance to update some of this, but looking at some work on ruby ray grapefruits in Vero, which was this block is surrounded by windbreaks to try and keep down the disease. Canker trial was started this is in 2020. It was delayed a little bit by COVID shutdown, so the first application went out in June. However, there was a general field application in May of copper, and they did applications at 145 gallons per acre. And you can see that they were doing a 21-day interval here from June when they could get out there until October, end of October in 2020. Looking at the canker incidents, most of these, I haven't got them named because they are experimental products, but they were all based on metals, I think most of them, but you can see that they're all doing fairly well in comparison to Pesticide. And then here's our untreated control. You can see that everything's doing very well compared to that. Do want to point out though that we're only at a 12% fruit incidence. So without too many applications, but we're able to keep it down to a 12% incidence at most. And that has to do with the fact that it was extremely dry in the spring of 2020. And not so much about the efficacy of any of the products. So, and as I mentioned, there was one general copper spray in May. Oops, wrong way. And I want to show you the rainfall in the Indian River was really the driving factor on that. Not only was the spring very dry, you can see that red is the 2020, and then here's the blue is the average amount of rain that they were getting over about 10 years. You see January was quite dry, February was normal, March there was no rain, April was a little bit higher, May sort of on average, June pretty close to average, but then July, August, and September were very dry for Vero Beach, and then it picked up again in October. So all of this dryness during this critical period for the early lesions, I think that saved the growers bacon in that particular case, especially since they didn't have the sprays out. And then this lull in rains here in the summer. So that kept our disease incidence low. We saw a somewhat similar pattern this last year with the very dry spring, and then a little bit dry again over the summer, at least in that area. So with all of that, when looking at yield, did canker suppression improve the yield? Was it really worth it in such a year where it was kind of dry? Well, it turned out that those products helped improve the canker yield by 10 to 15 pounds per tree. So here's our untreated control. You can see it's only got about 40 pounds per tree. And then all of these products here, including the copper, had around 60 pounds per tree. So that was pretty good. So it does help. Canker control is still help keeping your fruit for harvest. As I said, every fruit right now is very important. We want to keep as many of them on there. Not just HLB is causing our yield reduction. When we ignore all of these other diseases, we're really ignoring them at our peril in terms of thinking about everything else. We're not growing these trees, unfortunately, in a vacuum. That might be easier. So those are my final remarks. And I just want to quickly acknowledge all the people that have helped us collect this data over the years. Members of my lab, members of Evan Johnson's former lab, and then members of Oscar Bachman's lab that helped us with the black spot. Really very helpful. And I'll take any questions if there are any.
Thank you, Dr. Dewdney. If you have a question or a comment, please unmute yourself and speak up. Again, thank you, Dr. Dewdney,
You're welcome.
for a very important presentation. Thank you, Julie and Jean. And
You're welcome.
again, if you need CEU, send an email to Jean with your license number. And we will see you next month. Thank you all.